Hello everyone, welcome to this session. In this session, we are going to discuss the quick solutions of All India CAST Test Series JEE Advanced 2020, Test 3A. I have paper 1. Let's start with the first question of chemistry section. This is the first question we have. It says, how many total number of formaldehyde molecules are formed due to reductive ozonolysis of the given molecule? This is the given molecule. On reductive ozonolysis, let's find how many formaldehyde molecules will be formed. Here we can see we have one carbon, therefore one formaldehyde molecule will be formed here. Similarly, these are the formaldehyde molecules formed in this reaction or with this compound. So we can see 1, 2, 3, 4, 5 and 6. So total 6 formaldehyde molecules will be formed in this reaction. So if I go through the options, the correct answer is given in option B. Now let's move to the next question. This is the next question we have. It says, which of the following pair of molecules or species contain an anti-aromatic and aromatic molecules or species respectively? So students, here we have 4 options. For each option we have 2 species. So according to the question, the first species should be anti-aromatic. The second should be aromatic. So if I talk about anti-aromatic compounds must have planar ring. It should have throughout conjugation. Also, it should contain 4 and pi electrons. On the other hand, if I talk about aromatic molecules must have planar ring throughout conjugation. Also, it should contain 4n plus 2 pi electron. So if I talk about option A, the first species or the first molecule is 8-annuline. Here, the molecule is not planar. So this is neither aromatic nor anti-aromatic. So this will be a non-aromatic compound. The second species satisfies all the conditions for aromatic compound. So it will be aromatic. If I talk about option B, the first species is aromatic. The second species is anti-aromatic. For option C, both the species given are aromatic. Now if I talk about the D option, the first species is anti-aromatic, the second is aromatic. So if I go through all the options, we can see the first we should have anti-aromatic, the second species should be aromatic. So the correct answer for this question will be option D. Now let's move to the next question. This is the next question we have. It says, consider the following 4 molecules. These are the 4 molecules we have. It says, which of the following statement is incorrect? Here we need to find the incorrect statement. Let's go through all these statements one by one. The first statement says 1 is more basic than 2 and 3 in gaseous phase. If I talk about 2, here we can see we have minus I minus R group. So 2 will be less basic as compared to 1. Again, if I talk about the third option or third molecule, here we can see we have 2 benzene rings. So benzene ring due to resonance decreases the electron density on nitrogen atom. So 3 will also be less basic as compared to 1. So this statement is true. Now if I talk about the B statement, it says 4 is more basic than 2 and 3 in non-polar solvents like benzene. So if I talk about the fourth statement, here we have plus I effect of ethyl group. Now 4 is more basic than 2. It is correct because 4 is more basic than 1. So 4 is more basic than 2 as well as 3. So this statement is also correct. If I talk about the C option, it says 4 is most basic among all in gaseous phase. Yes, it is right. 4 will be the most basic species among all the 4 species. Hence, this is a correct statement. If I talk about the D statement, it says 1 is least basic among all in polar solvent. If I talk about all 4 options, 1 is more basic than 2 as well as 3. So this statement cannot be right. Hence, this is a false statement and the correct answer for this question will be option D. Now let's move to the next question. This is the next question we have. It says methane is chlorinated to give A, which further undergoes series of reactions to finally give H. So this is the series of reaction. Identify compound H. If I talk about the compound A, it is mono derivative. So I'm talking about mono-halo derivative. Methane, when reacts with chlorine in presence of sunlight, it will give you CH3Cl. So this is compound A. The second reaction is Core-House synthesis, CH3CH2 whole twice, CuLi. So it will give us propane. This is compound B. Now on chlorination, it gives mono derivative. It can be 1-chloro or 2-chloropropane. I am writing the major product. So this is B, this is C. With alcoholic KOH, elimination takes place and it will give us propene. Now, this is D. When D reacts with N-bromosuccinamide, allylic substitution of bromine takes place and this is the product formed because this is allylic position. So this is E. Now, it reacts with sodium and dry ether, that is Wurz reaction. So on Wurz reaction, it gives us CH2 double bond CH, single bond CH2, CH2 single bond CH, double bond CH2. Now here we are using, this is F, here we are using HBr, 2 equivalents of HBr in organic peroxide, which is benzoyl peroxide here. So anti-Markovnikov addition takes place and this is the product formed. Br, CH, 2, CH2, 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 Br. This is 1,6-dibromohexane. Now when it reacts with sodium and dry ether, again intramolecular Wurz reaction will take place and because of which cyclohexane will be formed. This is compound H. So out of the given options, hence the correct answer for this question will be option A. Now let's move to the next question. This is the next question we have. It says the following statements are given. First is canonical structure of compound must have identical position of atoms. Second is stable canonical forms have major contribution to the resonance hybrid. Third is any one of the canonical structure explains all properties of the molecule. Fourth is during the resonance delocalization of pi electron may occur without changing the position of an atom. Which of the above statements are correct? So if I talk about the first statement, it says canonical structure of compound must have identical position of atoms. If I talk about canonical structure or resonating structure, the position of nuclei, or I should say atom, and sigma electrons remain fixed or same in all the resonance structure. Only the position of pi electrons changes. So this is a true statement. The most stable canonical form will have maximum contribution towards the resonance hybrid. Third statement says any one of the canonical structure explains all the properties of the molecule. This is a wrong statement. Why? Because if I talk about canonical structures, all the canonical structures or resonating structures are required to explain all the properties of a molecule. So this is a false statement. If I talk about the fourth statement, it says during the resonance, delocalization of pi electron may occur without changing the position of an atom. This is a true statement because in resonance, delocalization of pi electron takes place while the position of sigma electrons as well as the atoms remain same. So this is a true statement. So out of the given statements, we can see 1, 2 and 4th statement are correct. Hence, the correct answer for this question is option B. Now let's move to the next question. This is the next question we have. It says consider the reaction. This is the reaction. Identify the major product. We need to identify the major product among A, B, C and D. So if I talk about cyclopropane, when it reacts with acid, what will happen? This carbocation is unstable, because of which ring opening will take place and we will get an allylic carbocation, which on reaction with water giving us 1, 2, 3. Its IUPAC name will be prop-2ene 1-ol. So if I go through the options, the correct answer is given in option B. And the correct answer for this question will be option B. Now let's move to the next question.